numbers where if you had that many dots, let's say 225 dots, you could arrange them into a perfect square. Today, we are learning how to factor the difference of two squares. And the difference of two squares is when you have a perfect square minus another perfect square. The difference of two squares will always be a binomial. It will always have a minus sign in between. The first, in this case, they're using the letter A, will be a perfect square. And the last, in this case, they're using the letter B, will always be a perfect square. So the difference of two squares is a pair of perfect squares with a minus sign in between. We are also learning how that's related to the sum and difference pattern. A sum and difference pattern is when the firsts, in this case A, are equal, and the last, in this case the B's, are opposites. What's important about the sum and difference pattern and the difference of two squares is how they're related. If you have a sum and difference pattern and you multiply it, the product will be the difference of two squares. And what we're learning today, if you have the difference of two squares and you factor it, your answer will be a sum and difference pattern. We're also going to take a look at perfect square trinomials. Perfect square trinomials are, first of all, trinomials. Their first, in this case, they're using the letter A, is a perfect square. Their last, in this case, they're using the letter B, is a perfect square. And their last is always positive. And we're talking about how a perfect square trinomial is related to the binomial square pattern. The binomial square pattern is when a binomial is being multiplied by itself. Now, the important thing to learn today is that if you take a binomial squared pattern and multiply it, the product will be a perfect square trinomial. And then today's lesson is if you have a perfect square trinomial and you factor it, you will have a binomial squared for your answer. So now let's look at this difference of two squares. So first of all, it's a binomial. Check. Second of all, there's a minus sign in between the terms. Check. Third of all, the first term is a perfect square because the coefficient on the x squared is a 1 and 1 is a perfect square. This is a perfect square term. And finally, 16 is a perfect square because 16 is 4 times 4. So this is the difference of two squares. That's what x squared minus 16 is. You need to be able to look at that and realize that that is a difference of two squares problem. When you factor that, if you follow this pattern, if you factor it, you will end up with an answer of x plus 4 and x minus 4. So quickly, if we check this by foiling, our firsts will be x squared, our outers will be negative 4x, our inners will be positive 4x, and our lasts will be negative 16. So when we take our outers and inners and put them together, they won't equal anything. So that'll be a 0, and what's left is x squared minus 16, which matches the difference of two squares problem that we started with. So if you are factoring the difference of two squares, your factors will always be a sum and difference pattern. All right, now we're looking at a perfect square trinomial. What makes it a perfect square trinomial? Well, first of all, it is a trinomial. Second of all, the first is a perfect square. In this case, it's a 1. The last is a perfect square. In this case, it's a 25. And the last is positive. It's positive 25. So if we want to factor this perfect square trinomial, we follow the path this way, and our answer will be x minus 5 times x minus 5, or x minus 5 squared. So we're going to check this by foiling. So that's x minus 5 multiplied times x minus 5. And we're going to look at our first, outers, inners, and lasts. and we get x squared, and we get negative 5x, and we get negative 5x, and we get positive 25. So when we put these together, we'll have x squared minus 10x plus 25, which matches our perfect square trinomial that we had when we started. So if you notice that you have a perfect square trinomial, your answer will always be a binomial squared. All right, so here's a real example. They gave us 4x squared minus 9. And we want to figure out if this is a difference of two squares problem. And if it is, we want to use the pattern to factor it so that we can factor more quickly without so much guessing and checking. So the first thing we have to realize is that this is a binomial, and it has a minus sign in between its two terms. The first number is a perfect square because it's a 4. The last number is a perfect square because it's a 9. So now we want to factor this thing, and it's going to be a sum and difference pattern. So if we can remember the shortcut or the pattern, we know that we're going to factor it like this. And it's going to be a sum, and it's going to be a difference. So now we need to think of two things that we can multiply together that will give us 4x squared. And we know because this is a difference of two squares problem, and it's going to turn into a sum and difference pattern, that the firsts are going to be equal. So this has to be 2x, and this has to be 2x. So right here, our firsts are equal. That's what we want. And then our lasts are going to be opposite. So we need to think of two numbers that we can multiply that will give us 9. And so those answers are going to be 3 and 3. And so our lasts are opposites. So now let's check it quickly by FOILing to make sure that we did it right. So 2x times 2x is 4x squared. Negative 3 times 2x is negative 6x. Positive 3 times 2x is positive 6x. And positive 3 times negative 3 is negative 9. So these two middle terms will drop out because they add up to 0. And what's left over is our original problem. So the answer to this problem, the answer to 4x squared minus 9, when you are asked to factor it, will be a sum and difference pattern. And so the final answer is 2x plus 3 times 2x minus 3. And on this problem, we want to see if we have a perfect square trinomial, and we want to try to factor it. So we start off, and the first term that we have is an x squared. So that means it's got a 1 in front of the x, and so that is a perfect square. So it's a trinomial, it's a perfect square. Our last number is 64, which is a perfect square because it's 8 times 8, and our last number is positive. So now that we know it's a perfect square trinomial, we should be able to take a shortcut because our answer is going to be a binomial squared. So our answer is going to be a binomial multiplied by itself. So we want to get a binomial multiplied by itself. So we need to think, how are we going to get x squared? Well, that has to be x and x. How are we going to get 64? Well, it could be several different things, but we know it's a binomial multiplied by itself. So they have to be the same. So our lasts both have to be 8. And then we have a positive 64 and a positive 16. So our C is positive and our B is positive. So we will have both binomials with a plus sign in between. So for a quick check, FOIL, x times x is x squared, 8 times x is 8x, x times 8 is 8x, and 8 times 8 is 64. So that'll give us x squared plus 16x plus 64, which matches our perfect square trinomial that we started with. So our answer on this problem won't be what we have written down right now. I'm going to erase that, and I'm going to write x plus 8 squared, a binomial squared pattern.